All right, in 8.3, we're just going to continue on what we learned yesterday with the sine, cosine, and tangent, and we are going to solve right triangles. So, example 1, use the trig ratio cosine of A is equal to 24 over 25 to determine which angle of the triangle is angle A. So, the first thing we need to do is put this fraction into our calculator. So, when you put 24 over 25 in your calculator, what do you get? 0.96. So we need to see which angle gives us that same 0.96. So if we take the cosine of anything, right, what is it when we do SOHCAHTOA? Adjacent over hypotenuse. So the cosine of angle 1, so looking at this angle, what is adjacent to angle 1? 1.4. And what's the hypotenuse? 5. So now we need to put this number into our calculator and see what we get. So 1.4 divided by 5. 0.28. So it's not the same. So now let's find cosine of angle 2. What is adjacent to angle 2? 0.8. .96. So that's the same. So when it asks which angle of the triangle is angle A, angle 2 is angle A.
So you have to try out all the angles?
Yes. Yeah, you have to try both the angles.
But how do you put something, because like when it says cosine, it has the little thing to put a number. So what do you put instead of a number?
So we're not actually putting the cosine in. We're just finding what this fraction is. Yeah. So let's do an example like that. This one, I accidentally erased the ratio, but it was sine. Let me look it up. I forgot. Sine A is equal to 8 over 17. So the sine of A is equal to 8 over 17. So now we need to find what 8 over 17 is in decimal form. So what's 8 divided by 17?
0.47.
0.47?
You want me to round to the hundredth, right?
Yeah. So now sine in general is what? Looking at SOHCAHTOA. Opposite over hypotenuse. We know that because of this acronym that you have to know for the quiz. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Yeah.
Another way you can write it to remember, can't you just do like S and then O over H and then C and A over H?
Yeah, but how do you know to use like opposite over hypotenuse?
Because we're dealing with sine. So we're looking at the one with the S.
Never mind, okay.
So this one's for sine, this one's cosine, that one's tangent. So we're looking at the one with the S. So sine of angle 1. What is our opposite of angle 1? The side opposite of angle 1? 27. And what is the hypotenuse? 30.6. So what do we get when we put this into our calculator? 0.88. So not what we're looking for. So let's try the sine of angle 2. What side is opposite of angle 2? 14.4. And what's our hypotenuse? 30.6. So now we're going to put this fraction into our calculator. 0.47. So that's exactly what we were looking for. So sine of angle 2 is going to be the same thing as sine of angle A. So angle A is angle 2. We have one more. So let's do tangent. So in SOHCAHTOA, which one's tangent? Opposite over adjacent. So the tangent of A is opposite over adjacent. So let's look at the tan of angle 1. What is opposite of angle 1? 27. And what side is adjacent to angle 1? 14.4. So when we put 27 divided by 14.4, what do we get?
1.875, so
1.875, which is exactly what we were looking for. So we can stop here because we know that angle 1 is angle A. It doesn't matter. As long as you circle it, just show that you got the same thing for angle 1 as you were looking for. If you know the sine, cosine, or tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measure of the angle. So before, what we were doing is taking the sine of an angle, and that's equal to some fraction of the side over the side. So we were always taking the sine of an angle. Now we're going to do the sine of that fraction is going to be equal to the angle. So the inverse sine helps us find the angle. So before we were taking the sine of the angle, but now we're taking the inverse, so sine -1 of that decimal, and that's going to help us find the angle. We're going to do lots of practice. So in the calculator, there's a button that says sine -1, cosine -1, and tan -1. So these are all the inverse of sine, cosine, and tangent. And the inverse gives you the angle degree. So in your calculator, put cosine -1 of 0.97. What do you get? 14. It says round to the nearest degree, so we can just leave it as 14 degrees. So we're putting the cosine of some decimal, and it gives us the angle measure, which is 14 degrees.
Wait, I didn't get that.
Okay, so now let's try tan -1 of 2.
So you put that number.
So you just put it in your calculator.
That's -2.
So you have to, there's a button that says tan -1. So some calculators, you click tan -1, and then in the parentheses you'll put 2. And then what does it give you?
63, sorry.
63 degrees.
What is error?
Okay, and then what do you get when you put sine of -1? 36 degrees. So the inverse functions, these cosine -1, tan -1, and sine, will give you the degree measure. So using given measures to find the unknown angle measure or side lengths of a triangle is known as solving a triangle. To solve a right triangle, you need to know 2 side lengths or 1 side length and an acute angle measure. So if we were given just 2 side lengths of a right triangle, we'll be able to find all of the angle measures and all of the side lengths. If we were given just 1 side length and an acute angle, we'll be able to find all the side lengths and all the angle measures. So that's all we need to solve all the parts of a right triangle. We're going to skip this next slide because it has the answer on it, and go to slide 9. So we're going to find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. So we have EF that we need to find, which we can call X, FD, which we can call Y, and angle D, which we'll just call it angle D. So what do you want to find first? Let's find x. So we're given angle F is 58 degrees. We're also given that ED is 14. So we're given the opposite, and we're looking for the adjacent. So in our SOHCAHTOA, which one involves the opposite and the adjacent? Tangent. So we're going to take the tangent of 58, and that's going to be equal to the opposite, which is 14, over the adjacent, which is x. So here we're trying to find x. So in order to get this to x equals, we can multiply x from both sides. So we get x times tangent of 58 is equal to 14. Divide tangent of 58. So we get x is equal to 14 over tangent of 58. So in your calculator, you're going to do 14 divided by the tangent of 58. So you're going to put this into your calculator. You're putting this into your calculator.
Yeah, no, but like, why are we finding x and not y?
One step at a time.
Oh,
8.7.
8.7.
oh, because we saw
Did I
x.
put it in right? Yeah, okay.
Yes. Okay, so now we found x. What do you want to find next?
Y.
Y. So let's find y next. What can we do to find y? Casey.
We can still all use angle F, so we're trying to find y, so we're going to find the adjacent. No, wait.
So we're still using angle F.
Opposite and adjacent.
We can use opposite and adjacent. Which one involves opposite and adjacent? Well, if we do opposite and adjacent, none of those involve y. So we're trying to find y. So we need something that involves the hypotenuse. So we have the opposite and we have adjacent. So we can either use the sine of the opposite over the hypotenuse, or we could do the cosine of the adjacent over hypotenuse. It doesn't matter. Either one. We'll get the same answer. So we can do sine of 58 is equal to the opposite over the hypotenuse, so 14 over y. So now y is going to be equal to 14 divided by the sine of 58. So you're going to do 14 divided by the sine of 58 in your calculator.
16.5.
So y is equal to 16.5.
Yeah.
What happens if you do the sum?
So 16.51. Remember, your quiz is going to be multiple choice. So whatever is closest to your answer. Next, we need to find angle D. So now we're looking for the angle. So we're looking for the degree of the angle. So we have all three side lengths now. So we can either do sine, cosine, or tangent. Which one do you guys want to do? Cosine. So we're going to do the cosine of angle D is equal to, what's cosine? Adjacent over hypotenuse. So adjacent is,
16.51.
what's adjacent to angle D? 14. And what's the hypotenuse? 16.51. So in our calculator, you're going to do 14 divided by 16.51. And what do you get? .848. So now you're going to do the cosine -1 of 0.848.
How'd you get them? So make 0.8.
We divided this.
So we do 16.51 divided by.
14 divided by 16.51.
32.
Oh, okay.
Wait, why is it cosine negative?
So here, since we're trying to find what angle D is, we need to do cosine -1 to find the angles. So the inverse will give you the angle measures. Sandeep, what'd you get?
32.00.
32. It says round to the nearest degree, so we can leave it as 32.
Okay.
What do we know about all three angles in a triangle? What do they add up to? 180. So all three of these angles in the triangle will add up to 180. So if we do 180 minus 90 minus 58, what do we get? 180 minus 90 is 90. So then 90 minus 58 is 32. So we would get the same answer. So if it gives you two of these angle measures, all you have to do is subtract it. You just have to take the acute angle, 58, and subtract that from 90. So 90 minus 58 gives you 32, which is the same thing as doing this. Any questions on this one? Okay, we have like 4 more examples that are just like it. So a highway sign warns that a section of the road ahead has a 7% grade. To the nearest degree, what angle does the road make with the horizontal line? So we have a road that has a 7% grade. When the grade is 7%, that means for every 100, let's say feet or miles, it doesn't matter, we're increasing 7. So this is what our triangle will look like. So it's asking, what angle does the road make with the horizontal line? So it's asking for this angle here, angle X. So what can we do to find angle X? Casey.
Use the tangent because we have the opposite and adjacent.
Perfect. We're going to use the tangent because in TOA, we use the opposite and adjacent. So the tangent of angle X is equal to 7 over 100. Perfect. So since we're trying to find the angle, we're going to use the tan -1. So we do tan -1 of 7 over 100.
4.
So you get 4 what? What are we talking about here?
0, 0.
Degrees.
Oh, yeah.
So 4 degrees. If we wanted to, we could find every single part of this triangle. What would the other angle be?
Oh, 86 degrees.
86. We just do 90 minus 4.
Yeah.
So this other angle would be 86. And how could we find the hypotenuse? If we have 2 side lengths, how can we find the hypotenuse? What's that formula that we use all the time? From a different chapter. Let's find the hypotenuse in a right triangle. Pythagorean Theorem. A squared plus b squared is equal to c squared. So we can use that to find our hypotenuse. We could also say the sine of x is equal to 7 over the hypotenuse. So there's different ways that we can find the hypotenuse. Okay, next example. Baldwin Street in Dunedin, New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does Baldwin Street make with a horizontal line? So we're going to draw our triangle again. Our bottom is 100, and the height is 38. So we're looking for this angle again. So angle X. What do we need to do to find angle X? The tangent of X is equal to
Is
the opposite over adjacent, so 38 over 100. So we're going to do tan -1 of 38 over 100. And what do we get?
0.38.
So you get 21 degrees. So if this angle here is 21 degrees, what's our other angle going to be? 90 minus 21, which would be
Oh, not 79. 69.
69 degrees.
That's what I said.
And then how could we find the missing side length here?
Pythagorean theorem.
We could do Pythagorean theorem, we could do the cosine, we could do the sine, we could do just about anything. So there's multiple ways we can find that missing angle, that missing side. Okay, let's do number 4. So we need to find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. So what can we do to find the missing side length here? Pythagorean theorem. So we can do 2.1 squared plus 5.3 squared is equal to c squared. So c is equal to 5.7. Does everyone agree?
Yes.
Okay, so now we can either find angle D first or angle F. Which one do you guys want to find first? Let's find angle D. So for this, it doesn't matter which one we want to find first. We can do either one. Just a personal preference. So we have all 3 side lengths. We have the opposite, we have the adjacent, we have the tangent. What do you want to do to find angle D? We can do sine, cosine, or tangent. Let's do sine. So if we take the sine of angle D, what is the sine? Opposite over hypotenuse. So we're going to do 5.3 over 5.7. So we're going to do sine -1 of 5.3 over 5.7. Remember, you do the sine -1, the inverse, when you're trying to find the angle. (22 degrees). Everyone agrees? We got 22 degrees for angle D.
Yep.
So we get 68. Remember, you're doing the sine. I think you might have done the cosine on accident.
Okay.
So angle D is 68.
I think you did angle F.
So angle D, we do the opposite over the hypotenuse.
Yeah, I think she
Oh.
did angle F. 'Cause I got 24.
So to find angle F, we could do the cosine of 5.3 over 5.7, or we could just do 90 minus 68.
Oh, yeah.
And what do we get?
22.
22. Okay, we have one last problem. Any questions on this one? So here it gives us an angle measure and a side length. How can we find the other angle measure right off the bat? So angle B.
90 minus 75. Oh, sorry. Never mind, I was looking.
Yeah, 90 minus 75. So what is angle B? 15. Okay, what are we going to find next? We can find AC or CB. Ton, which one do you want to find next? AC or CB? Okay, so let's call AC x. So what do we do to find x? So we could either take it from the perspective of angle B or angle A. So if we're looking from angle B, x is the opposite, and we have the hypotenuse. So which one in our SOHCAHTOA sine uses the opposite and hypotenuse? So we'll do the sine of angle B, which is 15, and that's equal to, what's opposite of angle B?
No, wait, my bad.
AC, which we're calling x, and what's the hypotenuse?
Square root of 6.
Square root of 6. So x is going to be equal to the square root of 6 times sine of 15. Because I just multiplied the square root of 6 on both sides to get x by itself. So you're going to put this into your calculator.
So you can actually do sine is the square root of 6. You can do that?
Well, you're taking sine of 15 and then just multiplying that by square root of 6.
Oh no.
I think you're right.
Right?
Yeah.
Oh, legend.
X is equal to 0.6.
I bet.
Okay, and lastly, we need to find BC. So let's call this y. So what can we do to find y?
You're asking me.
Anyone?
To find y,
Mm-hmm.
we could do angle B.
So from the perspective of angle B, what can we do?
You could do adjacent over hypotenuse,
Let's do adjacent over hypotenuse. So
which is
cosine
cosine.
of angle B is equal to, what's the adjacent? Y. And our hypotenuse is square root 6. So we're going to multiply both sides by square root 6. So we get y is equal to square root 6 times the cosine, angle B is 15. So the cosine of 15 times square root 6.
How about 2.4?
So y is equal to 2.4. Does everyone agree? So 2.4. Good job, guys. If we wanted to test our work, we could do the Pythagorean Theorem and see that 0.6 squared plus 2.4 squared is equal to square root of 6 squared. So if this checks out, then we know we did it right. So when in doubt, if it's giving you two sides, you can always do the Pythagorean Theorem. And if you are trying to find an angle, you have to use the inverse of the trig functions. So that's when you use like the sine -1. Any questions on 8.3?